just a subgroup of triangular matrices with ones on the main diagonal. So, and I told you that this algebra has a SL3 module. SL3 U as SL3 module is the sum of all irreducible representations with multiplicity 1. It's the sum.
Yes, I question that.
Yes, I will.
But it is
say
true.
Something about it.
The statement is true.
This statement is true. But maybe also your statement.
No, my statement is true. Maybe
Yes,
they're both.
yes. No. I would say something about Rita's statement also. Is the sum of all reducible representations with multiplicity 1. And Rita said that also.
Let's not forget there is a blind spot.
Yes. It's not.
No, I remind you, that's all.
Yes, Rita reminded us about the Borel-Weil theorem, which says something similar. So if G is good enough, then we consider a Borel subgroup, B Borel.
It's all representations of SL3, right? SL3.
Yes, as SL3 modules.
Yes.
So if we consider all, so B a Borel subgroup and T a torus.
G is reductive, right? Or semi-simple. What is it that we want? Okay, we don't want.
Connected, simply connected.
Yes.
Simple. SLN.
No, SLN.
No, of course, no. All classical groups.
Or classical.
T a torus, and we consider a character, lambda, the torus, the character.
But today we promised we were doing something new. Okay.
Yes, I wanted to remind you of this and see the difference of the two. So this character can be extended to the Borel subgroup. Can be extended to B. This is classical because B is just the product of T times U, and you just
Uniquely extended to B.
That's a unique decomposition. And we impose that lambda be equal to 1 on the unipotent group. So we can define a sheaf on G, but I don't want to define the sheaf. I will just say what are the.
I want to define a line bundle. The sheaf, you mean
the complete section.
It's more than just a sheaf, right? It's line bundle.
Yes. But I will just define the H0 of the sheaf. H0 G and lambda. So L lambda is the lambda. This is the set of all functions f from G. From G to C, C such that f of g times b equals fg times lambda b. Maybe I can say lambda b times
Is this a sheaf on G or G mod?
Yeah, it will be a sheaf on G mod B, but for now it defines it on G, right?
yes.
But it will be on G mod B at the end, right?
Yes. So these functions are not functions on G mod B, because you see it's not well defined on mod B, because we have this coefficient.
You don't want a minus one, you want lambda B, not lambda B minus one. This is the question. Okay, whatever. This means that I
Doesn't matter, I'm not very precise.
Okay, you decided what is it. Okay.
But in any case, these elements belong to this 0 G lambda are inside 0 G mod B, which is a projective variety. So that's the main difference from my point of view. This is a projective variety, while G mod U is an affine.
Yes, yes, yes.
So in this case, we consider real functions on this variety. While in this case, we don't have functions. We have
the word real can be misleading.
the word.
Real can be misleading.
Yes, real actual functions. Things that take values on elements of the.
Because it would be interesting to look at the real function, but this is a different story.
And the theorem of Borel-Weil said that this H0 G lambda is isomorphic. It's isomorphic, it's not isomorphic, it's and irreducible representation for G with highest weight lambda.
Right.
So of course, if we consider the sum of all these cohomology spaces, the sum of all lambda, if lambda is dominant, lambda will be dominant. H0 G lambda. So since these are the irreducible representations, if I consider the sum of all these, I have a G mod which is by construction the sum of all irreducible representations. What is not clear to me is that this is
No, it is equal.
isomorphic to this.
Yes.
Maybe, probably it is, but
No, it is. It is Borel-Weil about that, Stephen, isn't it?
But I mean, well, in the statement I found it says that this is the irreducible representation with the highest weight lambda. What is not clear is that this sum is actually
Yes, yes.
the homogeneous
I promised to look, but I didn't look.
But it probably is. I mean,
Okay.
I don't know. I just don't. For SL2 is true. I can work this out. In the case of SL2,
Well, yes, it is.
SL2
This is ridiculous because it's.
mod B, SL2 mod B is P1.
That's a polynomial ring.
this is the polynomial ring into
Right.
variables. So let's see xy. And to see the difference with this other space, we consider SL2 mod U.
Ah, that's interesting, that comparison.
This is a affine space minus the origin.
This.
Where
I forgot.
what? Turn it on.
I'm a disaster.
Okay, so in this case we have the coordinate ring is still this algebra polynomial, so they are actually the same.
Right.
But I don't want to go further in this. I just want to look at this example. To
Yeah,
show
well,
that
the structure is
the
different
structure of cluster
because-
algebra on this SLP
Yes,
model.
yes, okay. Because that's one case is homogeneous ring, the other is not. So it's,
So let's look at this example and see why this is a cluster algebra.
it's
The
not
principle of what we know about cluster algebras.
sì, però cioè, non si vede cosa vuol dire. Ma come si fa a vedere la batteria?
In any case, so let's see this. Set of SL3 on U. So on this page we have Blocker coordinates which are similar to the Blocker coordinates on Grassmannians that we have seen in the previous lectures. So consider.
So Fabrizio, what are you doing now?
I want to describe the structure of this algebra.
Just the structure, okay.
And see that it looks like the coordinate ring of the Grassmannian of planes in.
Well, certainly it must, because if it's true that the two rings correspond, right, the one G mod B and G mod U, because the statement that we discussed before was that G mod B as homogeneous ring is the same as G mod U,
Yes.
right? Then,
But we don't know that the ring of G mod B is a cluster algebra.
no, we don't know, but I'm saying that SL3 mod B is the flag, right?
Yes.
So, of course, that must look like the flag too.
Oh, yes.
That's what I'm saying. If we accept the Borel-Weil bot, then it's clear that what you're going to do, no?
Yes, but I want to do it explicitly.
So it will be the flag ring, will that be? Because that will be an evidence that... no, it's very interesting because we're making two claims. One on a ring which is looked at as homogeneous ring, and the other one as a ring that...
Yes, but
I find
I
it
know
very
the structure of the homogeneous coordinate ring of the flag variety.
Oh, I know it very well, so I'm just...
So I can tell you.
Very, very interesting, this thing.
So on this space, we consider the Blocker coordinate. So let's see if we consider. I take an element A. I11, I12, I33. The Blocker coordinates are the following. X1 is just A11. X2 is A21. X3 is A31. Then I have X12, which is the determinant of these 2 by 2 minors. So this A11, A22 x13, which is the determinant of the 2 by 2 9 or a11, a12, a31, a32. So a11, a32 minus a12, a31, and finally x23. Right, you have to write it. A minus a32, a so these are, first of all, these are well defined.
So you always take the first two columns?
Yes. Either the first column or the first two columns. In general, take up to the first n minus 1 columns, and we will consider all possible minors.
I mean, I know what's going on, but maybe they don't. So you should explain why these are the coordinates that identify uniquely an element in that.
Yes, you have to show that all the.
I mean, you have to do some work.
Yes, but I don't want.
You don't.
I don't want to do all this
Okay.
work. It's a. This is an exercise.
At least, yes, state what somebody has to do.
What are the exercises that xi and xij, first of all, are well defined. No? On SL3 of n, on
U.
U, and
We decided to go with you.
and they determine uniquely an element in SL3 module.
In the sense that
If you take two different classes in this quotient, then they have different coordinates.
and they determine uniquely means that
Separate points.
The separate ones. Okay, but the
Can I ask about the exercise?
now. Yes.
No, I mean, sorry. Choose at random 6 numbers.
Not at random.
No, that's
There are some
No,
relations.
there are
Okay, so
relations,
they
of
determine
course.
uniquely if they satisfy symmetry.
Yeah.
Under certain assumption, they determine uniquely an element in SL3.
Yes, there are relations among them.
There are relations. I say that they separate points. If
They
you consider
separate
two
points.
classes, they cannot have all the same coordinates.
Okay, that's
Can I ask about the
Yes.
So SL3 mod U is an affine variety. This we know from the theory. Because
Yes,
we
I don't
know,
know what you mean by affine variety. This is
Ah.
variety for you. It's a,
no,
it's a
that's
quasi-affine variety.
no. No, right. This is not an affine variety. This is actually the reason why I left algebraic geometry. Did you know this example exactly? Because I thought that this was an affine variety, I discovered not, so I decided that algebraic geometry was not for me. So I know very well that this is not an affine variety. So I know. Okay. Now this is kind of, now that I know it's not an affine variety, I'm slightly worried because why are we talking about the ring of functions on something which is not an affine variety? I'm confused now. You see my point? That is not an affine variety.
Yes.
That thing. How can we speak? I'm very confused because I think that's not a 2 minus 0, is it? No. So SL2 mod U is a triangular matrices, right? How do they look? I'm sorry, Fabrizio, I'm really confused.
No, the coordinates are just the coordinates of the first column. So if you consider...
Right. Depends on what you... So you took the upper... Oh, you take the upper. Okay. Right.
Yes.
So you're not... It's not really A2 minus 0, right? You want to avoid the whole line. Isn't that right?
No.
Yes.
No.
A has to be invertible.
No. One of the two must be invertible.
Right.
A must be 0 and B is not 0 and you have...
Right. No, you're right.
So
Now.
they cannot be both 0.
Right. Yeah, so there is...
And in this case, these two parameters determine...
Okay, so right now I explain what is my confusion. My confusion is I don't know the symbol CSL3 mod U because this symbol I use when the stuff that is in there is an algebraic variety. If it's not an algebraic variety, I mean there is no coordinate ring associated with it and I don't know what that means. Okay, what does it mean?
So, if it's an open set in a affine variety, then the coordinate ring is the coordinate ring of the affine variety, where it is,
yes.
where it sits.
Oh, so we're taking that. Okay.
In this
then
case, it's just A2.
Right. Okay. That is so. Okay, we're taking. No, because you can extend uniquely because that is a scheme, right? So you can always describe it.
Yes.
No, but you are right. I wanted to understand. So that those functions comprehend also functions that are not really defining that. That's all I'm saying.
Yes.
Okay, so because when I see that symbol, I think functions on, but that's not right. There are more than those. Okay. You see?
Can you read the last sentence?
Okay, so when he writes that symbol, C bracket SL3 mod U, these are not the functions on SL3 mod U, but there are also other functions that are not defined on that set. For example, if he looks at A2 minus 0, that CSL2 mod U is the polynomial ring, okay? That comprehends, no, these are also, I'm confused. That's right, it's a polynomial ring, but there are also the function 1 over xy, right? There could be, no, they're not other functions. I'm confused.
Markov theory that tells you that any function of math that's greater than 1 extend across
Right.
to 0.
Right. Okay. So it will be the functions. It's too tough. Okay.
So, let's go back to this.
Fabrizio, this is true in general for RBN. Is this true on SLN mod U?
Yes.
And you take just the first n minus 1 minus the columns.
Yes.
In that case.
So, in this case, I said there are some relations. But in this case, there is only one relation, which is
the Kluter, right?
yes, it reminds us of the Kluter relation, which is x2, x13. It's different from the Kluter relations on the plus minus, because in that case we always have minors of the same size, while in this case we have a minus of size 1 and minus of size 2. So it's not really the same, but reminds. So x2, x13 is equal to x1, x23 plus x3 x1. This is a simple verification. You just substitute a21 into x2 and all the others, and you verify that it is an identity.
It's not Klucker, I'm sorry. Klucker is when is homogeneous.
They call it Klucker relation.
They call it
in many
Klucker,
cases.
okay.
So, no, they call this Klucker coordinates.
Yes, but not Klucker, this is
not
a
Klucker
different
relation.
thing.
I don't
Yes,
know.
it's
In
not.
any case, this is just a relation. So this reminds us that in any case the Klucker relations on the Grassmannian, where we had the product of two variables was the sum of two monomials.
Yes, yes, of course, there are no relation among the xij's. Can I ask a question about the exercise? When you finish, I
Which is an exercise? This one?
Yes.
Okay.
No, have you finished what you want to say? Because I don't want to.
No, I want to say something
More, okay.
So in any case, this is the structure of a cluster algebra. So in this case, we have two clusters, which is of size 1. The first cluster is x2. The second cluster is x13. And we see that the product of these two variables is the sum of monomials. And one can go further. I mean, it's probably an easy consequence of this relation that all monomials which are not divisible by x2, x13. Of course, monomials in the sixth Klucker coordinates. All monomials in the Klucker coordinates. Which are not divisible by x2, x13, form a basis.
So this is a consequence of what? It's a consequence of what?
Of the relations. At least that they generate.
No. It's a consequence of the fact that you just have that relation.
Yes.
But you have not
The
proved
fact
this.
that you have this relation implies that these monomials generate.
No, yes, but I'm saying you have not proved that these are all the relations.
I didn't prove this. I'm just saying.
No, but you should, I mean, you should prove that in order to say this. It's not evident by itself, right?
No.
Okay, that requires some more.
Yes.
Of course, if we know the straightening, then we're done, because that will be a consequence. No?
Of course, it depends on what you mean by straightening, but this is
No, but I'm saying the straightening will prove this. No, I'm asking, okay, let me reformulate. How would you prove this? Let's formulate.
You prove this by showing that if you take 6 numbers that satisfy this condition, then they are coordinates of...
brutally. So you don't want to use...
I think you cannot prove it by straightening. The straightening...
No, I'm asking.
You can
it's
use
a
the
question.
straightening just to show that...
Right. Then geometrically...
the set of elements
okay.
generate.
No, you're right. Okay, you need to do it brutally. Check that...
and in this case, the straightening is easy. If you take any monomial,
Certainly.
if you have x2 times x13, you substitute by this.
That's very simple, yes.
So this basis is very special. Because we said before that this is the sum of all reducible representations. And they are special because any reducible representation is generated by some elements of this basis.
So this basis will give you the decomposition.
Yes. All irreducible
Tell me,
representation.
the monomials are the weights, right? Isn't this right, Fabrizio? The monomials will play the weight spaces, isn't it right?
The monomials?
I'm curious, I want to go ahead. The monomials will play the role of weight spaces? No.
I don't see what you mean.
Well, there is a representation, is highest weight representation, there is a dominant weight. There is a
formula of monomials.
Right, but I'm saying, not only this, but each monomial will play the role of a weight space.
Ah.
I'm curious, I want to go ahead. Seems, so it will give you a hold of this representation.
It might be, this is another exercise, I don't know.
No, you don't know, you're not going to prove this, okay. Because that seems, don't you think, Nicoletta, this seems very...
Not obvious at all.
These are determinants.
Okay, but why should be a monomial?
No, in fact, why? Really nice. No, okay.
I don't know, because it might be, but
You're not going to say this.
no.
Okay, too bad.
In any case, this basis is special because of this. Okay? All reducible representations in C as a rim of U are generated by some elements on this basis.
Again.
Then this is far from trivial. So in this way, we have obtained what is called a canonical basis for all reducible representation. So this basis is the canonical basis of this algebra, and the corresponding subsets, which are bases of the reducible representations, are called the canonical basis of the reducible representations. But then there are other canonical bases in the literature. We have the experts of quantum groups.
No, Nicoletta, of course.
And there is a relation, which I don't know, but the relation is that this basis is the dual basis of the canonical basis in quantum groups, in some sense.
What is canonical basis, Nicoletta? I don't
In
know.
quantum groups, I don't know.
You cannot say that just in 2 words.
Is it, but you know?
Yeah.
Okay.
So,
Is of
But I don't know what it means by you.
No, is in UG or is in the is in the universe? Is in universe.
this is the notation of the quantum
Canonical
group.
basis of the module.
Module for UG, UQG. UQG. That's why it is. Right. Because
This is the quantum group, whatever.
Right.
It has a canonical basis.
Well, it certainly must be dual because it's duality between commutative and co-commutative. That's clear, right? No, Fabrizio, dual is clear.
It's clear for you? Okay.
Yes, because that algebra is co-commutative, it's not commutative. So if you want to put a correspondence of the basis, it will be, right? I mean, it will be dual. The commutativity will move to co-commutativity. Okay, whatever.
I don't know.
No.
I don't know.
I understand why they say dual.
Because I want just to draw this picture. This quantum group, which is not a group,
No.
has a canonical basis.
It's almost a universal enveloping, but not really. Is this the ratio?
And there is a duality between this and
Is the usual basis for UQSL3 or is it a special one? Is it a special one? Okay. CQ.
CQ, right?
Right.
CQ.
Of SL3 must be, right? Right.
SL3, if I say
that's not
mod u,
good. That's not good, don't write it. What does he say?
Okay, in negative, these are things that I don't know, so...
But what does he say? He says...
he says this.
with CQSL3 mod u, he says that?
Yes.
I don't believe it.
So, Fabrizio.
No, there's no meaning to that.
Yes.
He says that.
But in any case, there is a duality between these two objects, which
The
form
okay.
a canonical basis for this.
No, I see what he means, okay. Okay.
Just consider this as a... And the limit for Q that goes to 1 of this dual canonical basis is the canonical basis that we have constructed in that
Very
in that
interesting.
example. And conjecturally, this is true for all good enough group connected, simply connected, at least for all classical group. This is known also only for SL3, SL4, and SP4. So it's just a small example of this.
But the canonical basis is known for all UQSLN,
Yes.
okay.
We have a canonical basis here for all elements, but it's not clear here the structure of cluster algebra or other things. So this is just
Fabrizio, here you give these coordinates on this space, okay? Then you can generalize that to SLN mod u. But that sentence is not clear in the case of SLN mod u.
no.
Not
No,
at all,
it's not
because
clear.
in that case the
Yes,
relations
no.
will have many
It's
more.
very difficult also for SL4.
Okay, but in the case of so you're claiming that this is true only in the case of SL4 mod u, or even
So the
even not in
conjecture
that
is that
case.
you have a cluster algebra structure, and you can obtain a basis considering monomials
Mhm.
in the variable of a given cluster, or not a given cluster. I'll tell you.
Questo è molto interessante, questa corrispondenza.
Sì, è già molto difficile anche nel caso di SL3 perché già la costruzione a base canonica non è,
difficile,
non
per
è
UQ,
facile, capito?
ok.
Quindi
So in generale,
UQSLN has been given explicitly the canonical
sì,
basis.
ha fatto Lustig.
Lustig,
Lustig
ok.
e Cascivara.
So the conjecture is that this is a cluster algebra, which means that you have a family of cluster, T1, Tk, probably maybe also infinite. Any cluster is a set of n variables. X1, X, and so on. Of course, there is there are not disjoints with these clusters. But we will
No,
see.
wait, I'm sorry. So T1 is this and T2 will be the determinants? No, what,
No,
I'm
so
sorry, what
in this
are you
case,
writing?
T1 is X2 and T2 is X13. That's it. There are only two clusters in these cases. But in general, you may have many clusters and also infinite clusters. And any cluster consists of n variables.
Ah, so you're writing X11 to mean is the first one. Okay,
Yes.
I got confused, I'm
You're
sorry.
right.
No, because it seemed it was like that one. No, but this is not what...
Maybe this is a bad
Yes,
notation.
sorry, because I got confused. That's
Yes.
my fault.
It's, and you consider the following family of monomials. You consider all monomials in these n variables, then all monomials in the variables of the second class, and so on. And all this family of monomial, all these monomials together form a basis of the cluster algebra.
This monomial. No, repeat.
You consider all monomials with these n variables.
No, wait. So I want to get the statement clear. So in this case.
So in this case, I mean, you have to recall that these elements are scalars.
Are what?
Scalars.
No. So T1 in that example, what is it? T1 in that example.
T1 is x2.
Is x2.
And T2 is x13.
Then it's not true that those form a basis. No, those are.
Yes, allora.
What are you
monomials in this cluster means
okay.
value is times a scalar, which is any polynomial in the other four variables.
Right. I keep forgetting. Yes. I should study, Fabrizio. I'm not studying.
Yeah, but I will tell you the definition today, so I hope it will be clear what we are doing. Okay, so we can start with the definitions.
No, I have questions.
Question.
I have some questions. I kept for the end. So, in that example, so you said, Nicoletta also said, what about the case SL4, right? For me, SL4, it offers no difficulty because you can repeat the same thing, can't you? What is the problem? You have x1, x2, x3, x4, then you have all of the 2 by 2 determinants, then you have the 3 by 3 determinants, and then you have those kind of Kluger relations, right? So you can really redo this. What is the problem?
The problem is to construct a basis at the end.
Okay, but as far as writing coordinates and relations, there is no problem, right?
Yes, but
no, you agree.
The problem is to construct a basis and then.
Then the basis, you say it will be a problem. The basis.
I guess I didn't try it.
No. Okay, so the key is the basis.
Yes.
Now, as for the exercise, okay.
This.
Yes, I want. Since I know I will not do it because I will go home and forget, let me be very...
You have your notes.
Eh?
You shouldn't forget, you've got your notes.
I have my notes.
You can read exercise.
No, I want to be arrogant and try to give my solution. So the way I will go about it is this. I will cover this with open sets. No, that's not right.
It's a trim-on-U.
I know it's affine. I mean, it's a quasi-affine. But what I will try to... No, it's not the right strategy to try to reason with an affine cover. No. Because...
That's a good strategy when you have a projective variety.
I know, but I was going to replicate here the strategy because A2 minus 0...
That's what Marta did for
I know, but if you take A2 minus 0 can certainly be covered by the affine. You just take the axis away, right? You can do that. I will try to do the same here. And try to, right? So that strategy will... let me rephrase. Have you done the exercise?
No.
Ah no, ma allora, scusa. Very unpleasant. I will do the exercise. So